I'm Paul Schrum, and I am a student at North Carolina State in the Masters in GIS Technology program. I'm also a roadway design engineer and a software developer. The tool that I wrote runs under ArcMap using Python. And if you find that you're interested in getting a copy of this tool, two things. One, you can get it here on GitHub, and I'll show it again as my last slide. And then the other thing is it's a little bit fragile. So if you find that you want to use it and then it crashes, let me know, and I plan to do two things. If you email me and say you're having trouble, I'll step you through the correct workflow. But the other thing is I plan to improve its stability so it doesn't crash so easy. And it's basically a user interface thing. The code behind it is working fine. So this tool runs under ArcMap. It is a semester project for a course that I took last spring at NC State, GIS 540. Some of you may have attended Dr. Tadeusian's presentation yesterday on batch processing with Python in ArcGIS. This course is a course that she teaches at NC State. It's available by distance education if you don't live near Raleigh and you're interested in taking it. The code is written in Python, and it makes extensive use of ArcPy, and it is a custom toolbox for ArcMap. And that's how it looks. I may pull it up, but I'm not going to run it, not because it's that fragile, but because, trust me, it runs. And I ran it last Saturday, and we're going to work with the data from last Saturday. So am I being heard okay in the back? Okay. So what does it do? It reads in polyline elements from a feature class. And it gets the points out of those. And I don't mean takes them out. I mean it reads them. It sorts the points spatially so that they're in order from beginning to end. And then for each triplet of points, it computes the curve parameters for the circular arc that those 3 points lay out. So any 3 points represent a triangle, but any 3 points also represent a circular arc. So that's what we're going to do, is get that data. It uses the back point, the current point, and the ahead point, and it computes radius and degree of curve and a few other things that you'll see soon. And it writes it out to a CSV file that you can then pull back into ArcMap or as a point event layer, or, so was it not recording? Oh. So then the ArcGIS Toolbox tool uses the points and computes the radius and degree of curve and some of the other values for those 3 points as they lay out an arc, a circular arc. And it writes the results to a CSV file, and then you can work with that data from the CSV file. So why do we need such a tool? Well, as you might know, most polyline feature classes are just, they're not lines connected by a point, they're points connected by a line. So that slide has got the terminology backwards. But it makes you read the slide, right? So if you have something that you know to be a circular arc, like a roadway alignment or a railway alignment, or something that you want to approximate as a circular alignment, a circular arc, like a stream, well, the curve information is just not there in terms of vector features. And so this is intended for people like roadway design engineers or planners or railway designers, or for people doing stream restoration design, so that they can get this curve information out of the polyline. So this presentation is going to be looking at a few questions. First of all, is my code working right? Does the tool give right answers? And the way that we're going to look at this is we're going to compare a polyline from NC1 map of a road in North Carolina with a MicroStation DGN file that NCDOT Roadway Design Unit used to design the file, to design the road. They used the file to design the road. And so we're going to compare curve by curve what information we get from MicroStation against what information we're getting from NC1 Map's PolyLine. So that's the first question, is it working correctly? But then, once I conclude, and I can tell you that I concluded it is working correctly, we want to compare the radius values and degree of curve values from the shapefile to those from the design file. But not really radius values. We really want to compare degree of curve values, because as you'll see, the radius values really flop around back and forth, and the degree of curve values are much more stable for the purpose of analysis. And then we want to evaluate, just in terms of asking ourselves, could this tool be extended to back compute the original design parameters? Now, this is the first few slides here are from my presentation that I did in my course, in the 540 course last spring. So there's a lot of code, and I'm not going to take the time to go into the details of the code, but you are looking at Python, and you can see, let's see, can you see my cursor? Yes. You can see here arcpy.mapping.map document, so there really is arcpy in here. And then this is a really busy slide. Let's see how much of this I want to look at. Yeah. So I'm going to show you all of the things that I'm describing here. If you want pictures, get them now, because I'm not going to spend much time on this slide. I'm going to show you graphically what it's doing. Also, I do go in and get a search cursor on the table from the shapefile from NC1 Map, and I go through each point and get out the geometry from that. Okay, so the image that I'm about to show, for the purpose of illustrating graphically how it works, these actually came from MicroStation. I'm a former MicroStation employee, Bentley Systems, Inc., and so I might be biased, but I'm more fluent in MicroStation than I am in ArcGIS. So this is not going to be my main test, but this is a test site that I did back in the spring, and that's Leesville Road in Raleigh. So down here is Interstate 540, and then you go north on Leesville Road, and there's a sharp curve. And then there's an elementary school right in here, just for people who might be familiar with the area. When we did the project on Leesville Road, we corrected this curve. This curve was too sharp. So the NC1 Map file that I used to get these points, that NC1 Map file did not yet have the new construction incorporated into it. So what I'm going to do is I'm going to show you with these 3 points what I did. We take 3 points at a time, but I'm going to focus on these 3. So the software that I wrote goes in and it goes to the middle of each line between points for that triplet of points. It goes to the middle, and then it turns 90 degrees, and it turns those lines, you can think of them as rays. And then it finds where those rays intersect, and that gives you the curve center. And then it puts the curve onto those 3 points. And it does it for all of the point triplets. I've only got a few curves shown here, but if I showed them all to you, they would be overlapping and it would be kind of hard to read. But the ultimate result, well, you can think of the ultimate result in 2 ways. Here's the CSV file that it generated for that run on Leesville Road. I've got degree and radius and those other things. Hopefully, if you like the tool, you'll find this information useful. But not everybody in here is a roadway design engineer, so let me review what degree of curve is. It's going to turn out to be important. So when you have a circle, you know you've got a radius, but that circle, if you take 1 over the radius, has a thing called a degree of curve. And in roadway design, when we do degrees of curve, we use 100 feet over radius. Instead of 1 over radius, it's 100 feet over radius. That's the value that I'm computing here. for degree of curve. Once you're done, this is all the radiuses for that section. And you can see down here that we flopped from the right to the left, and then the right, and then the left. Well, that's because this was in a straight line. So some of these radiuses are in the millions of feet. And that just means you're in what we call in roadway design a tangent. But then up here, look, that curve kind of transitions in, and then you get a pretty solid data point here where 3 of those curves are pretty close in agreement. Okay, more code. I'm not going to burden you with getting into that code unless there's questions at the end, if I even have time. So, asking the questions, reminding you the questions that we're asking. Does the tool work correctly? Let's do a road test. I thought of that pun myself. So what we're going to do is we're going to look at a specific area here. It's labeled up on the screen as 495. You may know it as 264. It goes from Interstate 440 eastward towards Rocky Mount. And it's not the whole thing. It doesn't go all the way to 440. But that red line indicates the location. So my method was I got the actual microstation files from NCDOT Roadway Design Unit, and then I compared the vector data from Roadway with the shapefiles that with the shapefile information as I got it from NC1 map and analyzed it with my tool. So let's look at some things. Let's look at it. How does this look in ArcMap? So here it is in ArcMap. You can see that this is Raleigh, this is Interstate 440, this is 540, and here's 264. So the section that I'm focused on is here in the red. I'll zoom in a little bit on that. And it turns out that there's 10 curves on the main line in that section. Also, one more thing I should zoom in on. The PolyLines that come down from NC1 map are actually 2, one for the eastbound lanes and one for the westbound lanes. I'm focusing just on the eastbound lanes. And how does it look from microstation? Well, first of all, I just wanted to demonstrate to you that I really do have the real microstation files. And then I'm going to turn some of these off. So that's everything. If I just did the alignments, it looks like, okay, that's not working right. Does that work? Okay, so in microstation, I was also able to take the shapefile and reference that in. And so that purple dashed line that you might see there is the shapefile itself. And then here are the edges of pavement. So let me zoom in on that. So here's the eastbound lanes, which I'm focusing on. But you'll see that the line that I used to make measurements, so I went over here and with the measure radius tool, I just click on it and it tells me that it's 12,108 feet. If you notice that there's an M right here, that's because I made a mistake in converting the coordinates, which I should have known better about. But it really is feet, and I have to ask you to trust me on that. So I just basically went down the line and asked it, what's the radius here? 3787, 3856. So that's how it looks from microstation. Also, I went over to be close to the shapefile, but I'm not right on it. That drifts left and right. Sometimes it's on the left side, sometimes it's on the right side. And if I compare it with the design file edges of pavement and lane lines, the line that I use for measurement is pretty close to the paint stripe between the leftmost and the center lanes. All right, enough of that. Let's go to, so I ran the tool, it generated some CSV files, then I imported the CSV files into Excel so that I could work with them. So on the left you see the X coordinate and the Y coordinate, and that's pretty hard to work with, but I did it anyway. And then here it shows the computed degree of curve. And there's a few outliers, so I've highlighted some of the outliers. and then the radius and arc deflection, chord direction, the deflection from just the 3 points, and the distance from point 1 to point 2, and the distance from point 2 to point 3. Then, still on this same spreadsheet, I went, okay, so this was in the kind of the academic track. So what would an academic track be without statistics, right? What I did was in this column, I just typed in by hand the radius that I got from here. So I got a radius from here, and I typed that in by hand, 12,108.24, and I did that on the 10 curves that I have. Then over here, it's probably hard to see, but I just use an equation in Excel to compute the actual degree of curve. So I'm getting the real degree of curve from the MicroStation files. They might not have built it exactly like this, but in this case they did. Then here, you might be able to see this says average, and what that's doing is I'm getting the average of all of the degrees of curve and radiuses through here. So when I look here at radius, okay, that average radius is 10,172 for the point that I selected. But for this area, the average degree of curve is 0.48, and the average radius is huge. As a matter of fact, it's so huge that when I compare the values by getting a ratio, this radius is 7.8 times more than the actual radius. But the degree of curve is very close. Now here the radius is not too bad. 0.92, 1.08, that's the ratios of the radiuses from the design file to the NC1 map file. But the degree of curve is much better. So what I've concluded is that, first of all, I've concluded I'm getting the right answers. Secondly, I've concluded that the files, the shape files from NCDOT through NC1 map, they have some noise in them when they're hand digitized. And that's not really a criticism, because I think they're doing a great job. And I'm very grateful to NCDOT GIS department for all the hard work that they do to get us this data. But still, I want to look at the data and analyze it and see what we've got. And what I've done is a kind of analysis of variation. I'm not sure if this is really analysis of variation. But I took the average over the 10 curves of the degree of curve ratio between the design value and the discovered value. And for degree of curve, that average was very close to 1, which is, it should be 1 if it was perfect. It's very close to 1. Now, is it moving, is it bouncing around a lot, or is it very tightly close to that 1.0? Well, the standard deviation shows 0.3, so it's pretty close. Coefficient of variation is kind of like the bandwidth. Coefficient of variation of 0.03 means that it's pretty tight. So then I did the same study on the radiuses. Well, the average radius ratio is 4.2, standard deviation 7.8. The coefficient of variation, the bandwidth, is kind of all over the place. It's very widely dispersed. So I compared how much more is the radius coefficient of variation to the degree of curve coefficient of variation. And basically that ratio is 54 to 1, which is really pretty big. So if you're going to be trying to figure out the radius of a curve from a shapefile using this tool, average the degrees of curve and then back compute what your radius. That would be a suggestion. And then finally, well, not finally, I want to ask a question of why is this so huge? 25 to 1, the ratio of the roadway design radius to the shapefile radius, average radius. And the reason is because this curve is very slight. It's only, I mean, it's got a huge radius and a very low degree of curve. When you have that, the person who's digitizing it may be zoomed in so much he doesn't even realize he's in a curve, or she may not realize she's in a curve. And so they might be going kind of back and forth. And I think that's why that happened, because of the hand digitization. But it really skews up those ratios. And so I've got about 5 minutes left, and I'm kind of surprised I got through it. Let me go back to my slides. It ended the slideshow. That's kind of frustrating. When I Alt-tabbed out of it, I've not seen it do that before. Okay. So that's just a review. These slides were to remind me if I forgot what I was doing. And so let's go back to the questions. Number one, does the tool work correctly? I believe it does. Number two, how does shapefile degree of curve values compare to design value degree of curves? I would say they're pretty good, but you need to have a way to address outliers. So if I'm using degree of curve to find places where you're going left, 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 right, left, 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 you want to take that sharp jog to the right out using statistics. And then could we use shapefiles to back compute design alignments? I'm convinced that this is possible to a certain level of uncertainty. You can't get it perfectly, and it's actually something that I hope to do in my time at NC State as a student, is to develop a tool that will take those and go all the way back. So roadway designers who don't have the original plans, they can use the shapefiles. Rail designers or stream restoration people. And of course there are no plans for streams, but you do need to know what those radiuses are. So I've got 3 minutes left. Do I have any questions? Yes? The question is, did I play with densifying, or did you say simplifying? The short answer is no, I didn't. And I'm not sure what that process would do. And so that might be something that I need to look at, especially if they are already doing statistical analysis on it. And it's certainly something I would like to use. Other questions? Well then, I finished a little early. Kind of surprised.